guys, welcome to VChem World. Today we will discuss on the closed packed structure. In the formation of crystalline, all constituent particles are well-ordered arrangement, means closely arrangement. For example, we consider constituent particle as an atom. This is the atom. Where closely packed means the minimum vacant and maximum occupied. In this structure, see that this is the close to each other, touching to each other. So in this two atom, occupied space is maximum and living space is minimum. For example, in this two, living space is minimum and occupied space is maximum. This is known as the closed packed structure. Then this closed packed structure gives the density of the material. For example, in the solid, all material are very closely each other. So its density is more than the liquid, and gaseous density is less because of the all molecules are moving freely. That way, when closed packing structure closely pack each other and its density is more. Density more and its stability is also more. So this is the all about the closed packed structure. Then closed packed structure divided into three: one-dimensional, two-dimensional and three-dimensional. We know that the constituent particles are varying shape and size. But we understanding easily, we consider as the constituent particle as a hard sphere and same size of the sphere. So in this one dimension, close packing in one dimensional, this hard sphere and same size. One dimensional means only row or column present. Only one direction. For example, X or Y or Z. Any one directional this present. Then this close packing means maximum occupy and minimum vacancy. This is the maximum occupation. Then this consider as the neighboring atom. When nearest neighbor atom, this consider as the coordination number. Nearest neighbor atom is 2 in this. For example, consider as this atom, its nearest neighbor atom 1 and 2. So this 2 known as the coordination number. Number of nearest neighbor atom, it's known as the coordination number. In this close packing in one dimensional, coordination number is 2. Next, close packing in two dimension. In one dimensional, only row or column present. Then two dimensional means row as well as column. Then two dimensional arrangement of this atom two different way: square and hexagonal close packing. On the basis of the first, we discuss on the square. The square close packing, first layer 1, 2, 3, 4, 5, 6, so on. First layer known as the name A. Then first layer arranged in row. Then second layer below the exactly same as the first layer. This layer are two same. So that way this is the row and this column arrangement and make a square planar close packing. The second layer same as first layer, so this known as the also A. Third layer same as first and second, it's also A. So we can say that its arrangement is A type arrangement. Then how coordination number find out? Number of nearest neighbor atom, it's known as the coordination number. For example, we consider this atom. Its closest neighboring atom 1, this 2, 3 and 4. So in this close packing, this 4 neighboring nearest atom. So its coordination number is 4. Coordination number 4. Why this is known as the square close packing? Because of in the arrangement of this atom, this shape is square. Neighboring nearest atom shaped square. So this known as the square close packing. Then next hexagonal. Hexa means 6. Gonal means side. That way square means 4 and hexagonal 6. In this arrangement, first layer same as the square layer. Square close packing. First layer same. Then second layer is between the first layer. Second layer is started with this atom between the first layer of the two atoms. So this layer is known as the A. Second layer is different from the A. So its name is B. But A layer is the same as the A layer. Third layer is same as the A layer. So it's known as A. Then next layer is B. It's arrangement of the AB type arrangement. Why this is the hexagonal? Because of in the nearest neighbor atom. For example, consider this atom. Its nearest neighbor atom 1, 2, 3, 4, 5 and 6. This shape is the hexagonal. Hexa means 6. So it's known as the hexagonal and its coordination number is also 6. In the square close packing, coordination number 4. In the hexagonal, coordination number 6. Coordination number more in hexagonal than the square. Because of the high coordination number, its close packing is very tightly. For example, in the square close packing, occupy space 52.4% of available space. This occupation, for example, this is the 100% space. And this atom occupies the square close packing. It available maximum space is 52.4%. And another is the vacant space. That same way hexagonal. Hexagonal occupies space 60.4%. So occupy space is maximum. So that is the tightly packed or closely packed. This stability is more than the square. Because of its occupied space is maximum than the square close packing. Next, close packing in 3 dimension. 1 dimension means only one direction like X or Y or Z. 2 dimension means two direction X or Y, Y or Z or X. And 3 dimension means X, Y or Z. Arrangement of atom in different direction for the 1 dimensional, 2 dimensional and 3 dimensional. We discuss on the 3 dimension. 3 dimension means this atom arrangement X, Y or Z direction. First we consider that the 3-dimensional close packing from 2-dimensional square close packed layer. In the previous we discussed on this square close packing. Square close packing, this is the 2 dimension. Why 2 dimension? Because of for example, we consider this is the X direction and this is the Y direction. So this is 2 direction present. 2 direction means 2 dimension. Consider this atom, its coordination number 4. It's known as the square close packed structure. 2 dimension. How to get 3 dimension from the 2 dimensional square close packed layer? This is the first layer. Then next second layer same as for the first layer. We consider that the second layer put on the first layer. In this figure see that the second layer on the first layer and third layer also same as the second and first layer. So first, second, third layer is the same. So this is the X direction, Y direction and Z direction. All atom arrangement are same. So this known as the cubic close pack. This consider as the A layer 1, it's known as the A. Second layer A, third layer A, then first layer repeated A, second layer repeatedly A, third layer A. So its arrangement is the AAA type arrangement. This type of packing is the simple cubic unit cell like packing. So its it's known as the primitive unit cell. Because of the primitive means all element present on the only corner. In this structure, see figure, all element present on the corner. So this is the three-dimensional square close packing. Next is three-dimensional close packing from two-dimensional hexagonal close packed layer. Three-dimensional packing means three layer, first layer, second layer and third layer. First layer we consider as a two-dimensional hexagonal close packing. The hexagonal close packing, this atom consider 1, 2, 3, 4, 5, 6. 6 nearest atom. Its coordination number 6. It's known as the hexagonal close packing. When this structure drop, this void, this known as the void. This is the empty space. It's known as the void, and its name is the triangular void because of the made up of the three sphere. So this void known as the triangular void. In this structure, two type of void, two type triangular void. First, that is the A and A. This is the B and B. So A and B type of triangular void present. When second layer put on the first layer of the hexagonal close packing. So second layer on the triangular void A or triangular void B. Second layer put on the started with the triangular void A or B. Not both the triangular void. Only one type of triangular void used. First we consider as the triangular void B. Second layer, this is the B. Start with this type. Then in the hexagonal first layer, first row and second row is the between the first. So this is the first and between the this we consider as a that way. We cover only B type of voids. This is the B types of voids. Then in this structure, these are 4. 1, 2, 3 and 4. That way 1, 2, 3. This is the B type of void. And second layer covered with B. So there are 4. 1, 2, 3, 4 lobe. 4 lobe means tetrahedral. And this empty space is known as the void. So this is the tetrahedral void. Then next 1, 2, 3. This black 1, 2, 3 and red 1, 2, 3. So 3, red 3 and black 3. So 6. 6 lobe means an octahedral void. This space is the octahedral void. Octahedral void 1, 2 and 3. Then 4, 5 and 6. 6 lobe present means octahedral. And this space is void. This is the octahedral void. In the next lecture, we discuss on the third layer on the square and hexagonal space. Thank you. Please like, share and subscribe.